Hi and welcome to this RIPEX2 tutorial on Babel protocol. This is part B of our series focusing on radio and relay filters. We will be using the same topology and base configuration as in part A, so please refer to it in case you have not seen the previous tutorial. Base configuration files may also be downloaded from this video's description. Also, in case you are not familiar with basic Babel protocol principles, please refer to part A tutorial where it is explained. With that aside, let's start. In firmware 2.1.7.0, we added a proprietary layer to Babel protocol with two new capabilities. First, enables Babel to control path priorities based on current RSS or MSE values using the radio filter. The second, controlling which of the obtained routing rules are being forwarded and which are not, called the relay filter. It can also be used to alter routing rule metrics and thus prioritize some of the nodes. These two features greatly improve Babel performance in radio networks, enabling RIPEX units to ignore bad quality links, thus increasing efficiency of the communication. Let's begin with radio filters. We recommend always configuring radio filters while Babel wireless types are set, because no dynamic routing technology takes RSS or MSE values into account. This improves resilience when using a narrowband channel, as RIPEX2 receiver can decode signals with low RSS or MSE, but for regular SCADA packets this path might not be the best due to potential data loss. The radio filters will drop some received hello packets, from radio perspective, low quality links, making them less attractive to Babel routing algorithms. You can set two thresholds, soft and hard. Hello packets worse than hard limit are always discarded. Hello packets better than the soft limit are always accepted. Values in between the soft and hard limits are sometimes discarded, with probability linearly increasing toward the high limit. Keep in mind that each modulation has its own sensitivity levels. You can find both sensitivity levels for RSS and MSE recommendations on our website. Please follow the QR codes or look for links in this video's description. For example, the whole network runs on Pi4 DQPSK within the 25 kHz channel. Sensitivity from the documentation is -111 dBm and recommended MSE is -14 dB. Default thresholds can be for RSS -111 dBm hard and -91 soft, calculated as 20 dBm fade margin. For MSE, a soft limit is -14 dB and hard limit -10 dB. The MSE hard limit is based on user experience and needs to be adjusted as needed. Let's see how to configure the new filters in our network from part A. We used a 25 kHz channel and 16 DEQAM modulation. Go to Settings, Routing, Babel, Radio Filter tab. There is no need to set individual thresholds, so after consulting documentation, we set RSS hard to -98 and soft to -78 dBm, and MSE hard to -17 and soft to -22 dB. These need to be set in all four units. Wait a couple of minutes and then check Babel status. Looking at Babel status from RIPEX-D, you will see the filter working since metric to 10.10.10.1 is increasing. That is caused by its measured RSS being below the soft threshold. See Diagnostic Statistics and select Radio Signal Statistics to see measured RSS values. Please note that if you combine multiple modulation within the network, individual link thresholds are recommended and should be set. See details in our documentation. Okay, now that we learned about radio filters, we may proceed to relay filters. Relay filters have many applications. End stations can be prohibited from forwarding rules to its neighbors. The station may also be set to disadvantage paths leading through that unit. or it may be set to limit the number of propagated routing rules to decrease the number of routes within the network. For example, if we have a unit at the end of radio topology and do not wish it to propagate any routes, we can set relay filter policy in Settings, Routing Babel Relay Filter to Reject. That would be a recommended setting for our Unit D. Looking from Unit A before this change, you could see routes through Unit D to other units. After the change, there will be only routes to Unit D, not ones through it. You can also increase metric for the routes being propagated, for example, to disadvantage a particular repeater. Let's set RipX C to increase metric obtained from this repeater by 100. Go to Settings, Routing Babel, Relay Filter and set Filter Policy to Accept. Then click on Add Rule. Select Match in the filter network, switch Increase Metric to On and change Edit Metric to 100. After the change propagates throughout the network, you can see the following routing table in Babel status in Unit D. Routes to 192.168.1.0 and 2.0/24 via 10.10.10.3 have the highest metric. Direct route to its own subnet is not disadvantaged this way. Routes can be also limited selectively. Let's go to Unit D again and make sure it does not propagate, only 192.168.2.0 and 3.0/24 networks. Go to the Relay Filter and change the policy to Accept. Then create a new rule setting filter network to match an IP to 192.168.2.0/24. Action needs to be Reject. Then we create a similar rule for 192.168.3.0/24. Looking from Unit C, we see it does not use 10.10.10.4 as gateway to reach 192.168.2.0 network. Obviously, it uses the gateway to reach 192.168.1.0 and 4.0/24. It is recommended to restart every unit after completing Babel setup for the first time to ensure every unit starts with a clean slate and the effects of the configuration can be quickly seen. And that is all I have for you today. Please see Babel tutorial Part C, which combines radio with Ethernet backbone. Thank you and have a great day.